Hello, everyone. Welcome back and to our session, Creating Digital Rule of Law with Alan Rodriguez. Quick introduction. Alex is a product and data leader with 20 plus years of experience envisioning and building cutting edge digital solutions. As the founder of Accessor, his team is creating media and data containers as programmable, transferable, encryptable, cacheable, and remotely controllable data building blocks designed to ensure the owners of data can constrain and direct its uses everywhere it flows and grows. So without further ado, Alan, it is all yours.
Thank you, Wayne. I'm going to flip over. Hello, everyone. I'm just going to flip over to my first slide here. So slide this down. So a lot's happened this last year and a little over a year, and people are looking for new ideas to big problems, and they're looking to do things about those problems. People are more open to new ideas now, and that's what we're going to be doing here. We're going to be talking about ideas, and I need to warn everyone, you're entering the land of ideas now. This is the first place these ideas that we've been working on for about a decade now are being presented to the public. And it's an honor to present them here. It's an honor to present them at MIT and at the CDOIQ Symposium and to present them to all of you. Let's see, we already did an introduction. So I'm Alan Rodriguez, and I'm the inventor and founder of Accessor, as well as the nonprofit Data Freedom Foundation. We're creating a standard for transparent and accountable data, and we welcome everyone here to join us. We're creating the technology for this transparent and accountable data. This is exactly what our keynote speaker, the Archbishop Vicenzio Paglia, passionately spoke about in our opening, when opening this conference. He talked specifically about the need for transparent and accountable ethical AI. And that's exactly what we're going to do, is we're going to talk about a standard to do exactly this. So our foundational premise is that data is lawless, not unlawful specifically, but lawless in the sense that it's out of control, that it's opaque and unaccountable. After 30 years of commercial internet development, we've created this amazing global digital marketplace. It's guided and powered by capitalist free market ideas, but it's paradoxically paired with these lawless data flows. Our early internet pioneers understood the seriousness of this problem. And between about 1997 and 2011, the W3C and the IETF worked collaboratively through many interrelated efforts to create control standards for our shared data. And we'll have a chance to review several of these in more detail shortly. But despite this extended effort, we never adopted any of these standards that couples our data with agreements that could effectively limit the data usage. It's strange to contemplate this reality, this sort of paradox of a free market internet with limited global government oversight, combined with almost entirely lawless data flows, opaque and unaccountable data flows. We can sign paper agreements, we can select terms of use checkboxes, we can pass legislation, but none of these actions directly impacts or automatically alters any actual data transactions. People must audit and remediate an exponentially growing kind of an ocean of data for compliance. So how bad is this, right? So Gartner has a very telling statement about the Internet of Behaviors. This digital marketplace is increasingly powered by AI-driven personalization. It's operating globally, where all of our thoughts that frame our reality as individuals are captured as data points and used to alter our beliefs and behaviors. This is done by the highest bidders. By 2023, Gartner predicts that the individual activities of 40% of the global population will be tracked digitally to influence our behaviors, to change what we think and what we believe. That's more than 3 billion people. The Internet of Behaviors is what this is being called. And Gartner says, I think very precisely, that this will challenge It's an amazing word for this. Challenge what it means to be human in the digital world. Our personal data is the blueprint for our individual reality, without which technology cannot interoperate with humanity, and humanity cannot interoperate with technology. Our data are both the inputs to the control of the technology around us, and then scarily, it's also the inputs to the slow manipulation of our beliefs and behaviors. We want all the good stuff, but we can't engineer out any of the bad stuff. We can't tailor the uses of our data sufficiently to dial in what we want and dial out what we don't want. So let's look a little more closely at these AI systems and how we might control them. This is the Journal of Artificial Intelligence Research published an article with researchers looked at superintelligence, and they cannot be contained. Lessons of computability theory. This is the article name. The scientists experimented with two ways to control artificial intelligence. The first was to design a kind of theoretical containment algorithm. This comic actually comes out of their research paper. So this is the containment algorithm, right? The team concluded, though, that no such algorithm could be created, sort of Asimov's 3 laws of robotics kind of thing. It can't be done with current computing paradigms. The other option, interestingly, that they contemplated was isolating the superintelligence, here's the Ethernet cable, from the internet and other devices, limiting its contact and its data interactions with the outside world. And they concluded this would significantly reduce its ability to perform its design functions because this limits its access to the data inputs it requires to interoperate with humanity. Yeah, I love this comic. This is very telling, right? This is the challenge we all have. How do we use the technology around us so that it serves our needs? And then how do we tailor that use and those needs so that it doesn't do the things that we don't want? And we're being faced with a sort of Boolean yet on or off situation. And that's sort of the base of our premise of the problem that we're facing with ethical AI and data and digital civil rights. And since no theoretical containment algorithm can be made, our only option is, and they say this in the paper, is tailoring our connections to technologies by isolating them selectively from our data. So let's start with rule of law. I keep coming back to this and this idea that we have to create it and that there's some value in doing this. So let's start with just defining the standard definition of rule of law. The American Bar Association has I think a very good definition. They say it's a set of principles or ideals for ensuring an orderly and just society where all laws and contracts apply to everyone equally. There are clear and fair processes. This is transparency and accountability again, for enforcing laws and contracts. There's an independent judiciary and human rights are guaranteed for all. Rule of law doesn't create an independent judiciary and it doesn't create human rights for all, but without rule of law, we have a hard time having an independent judiciary and we have a very hard time guaranteeing any kind of human rights. So what might digital rule of law look like? So I've taken the liberty to sort of adjust the definition slightly. So what we're saying here, this is our working definition for digital rule of law. We're saying it's a set of principles and ideals for ensuring an orderly and just digital society where laws and contracts apply to everyone equally and automatically. There are transparent and accountable processes for enforcing laws and contracts. And of course, there's still an independent judiciary, but now we have human digital rights being guaranteed for all. So this is our working definition. It keeps evolving. We keep working on it. But this is what we're aiming for. And do we have digital rule of law today? Do we have a just digital society? Do we have contracts and laws applying to everyone equally and automatically? Do we have transparency and accountability in processes? I would say no. So what happens if we don't have some kind of digital rule of law? What does rule of law do for a society? And maybe we can deduce a little about what happens if it's missing. Penn State has the best definition that I can find of what rule of law does. And it's foundational for any sort of economy. Rule of law is an indispensable foundation for a market economy, which provides an essential environment for the creation and preservation of wealth, economic security and well-being, and the improvement in the quality of life. So without digital rule of law, some kind of way to make that happen, we're missing an indispensable foundation for a digital economy. We're missing an essential environment for the creation and preservation of digital wealth. If this is our problem, right, this lack of digital rule of law, why has this happened? Why are we here today in 2021 with these amazing technologies around us, and we seem to have missed this part of the equation? What happened, right? So this is really interesting. Let's go back in time to the early days of the internet. I'm going to show you guys about about a dozen different interrelated efforts that attempted to do this exact thing. We're going to look at three of them. The first one is the policy-aware web between 2005 and 2006. This was their most advanced architecture at that time in 2006. In the top here, we see a bunch of policy stuff. On the left, we see authentication data, identity data. We see media. We see event data, entity data. We have this concept of a proof-capable reasoner that creates a proof, a result, a trusted result from the data, a checker, a result, and then an edge gatekeeper of some kind. This is the beginnings of a workable solution. The next step, and it appears, just by researching this, 2006 to about 2000, around 2006, we see a transition. This working group shut down, and it actually spun up a whole new set of working groups around the Transparent Accountable Data Mining Initiative. The TAMI project attempted to create this is their definition, a technical, legal, and policy foundations. And this is their words, for transparency and accountability. And they add some exciting elements, to me they're exciting, to the policy-aware web. Over here on the left, we're clearly talking about all data, everywhere. Over on the right, we have auditors. Here's this proof-capable reasoner again, creating the proof and the explanation. For auditors, we have analysts able to look at the intended use through the reasoner and determining whether it's appropriate or not. And this is the real powerful part of where they were by 2011. We have up here the policies up here are being informed by legal authorities. And this is the part that I love this. This might be a logo at some point, but it's the law cloud, right? So what they're saying here is we're connecting the law to all data on the internet, with all these other functions for analysts and auditors. Now, what's interesting in parallel was there was another group unrelated to this, appears to be unrelated, who was tackling this exact same problem, or policy-based control of data, but they were looking at it slightly differently, more like the way we're looking at it. They were looking at it as data moves between organizations. So the Inquiry project proposed an architecture where encrypted personal data with machine readable policies stuck onto it could only be decrypted and read by entities that abide by the policy rules. They explored a technique they called data tagging, or sticky policies, where users' personal information is labeled or tagged with instructions or preferences, specifying how service providers should treat their data. This effort envisions sticky policies, automatically enforcing preferences as personal data flows around multiple parties. This is the key distinction. Here we have the first standard where we're moving around data, and the data is carrying with it the rules for its use. Here we see the first effort to do this. We have data, here it is, transformation. Okay, so over here, this is the cool part. This is where they have the internal and the external workflow manager over here. This is the internal one, and then here's the external one, and they have a lot of interactions happening between organizational boundaries as data flows. This was 10 years ago when people were working on these things. Lots of groups were working on these things. So how might we do something like this today? How can we create a standard to bring accountability and transparency to data everywhere? So 10 years is a long time, and we've had lots of advances have occurred since 2011. The technology landscape is almost completely different from 10 years ago. We have many, many new technologies, many distributed technologies. And more importantly, we have entirely new ways of thinking about technology and data and the interconnectedness of our society. So what we've witnessed, one of the things we've really witnessed that's interesting is these repeating themes where there's been this slow and slow and steady accelerating march of software, control of complex hardware up the technology stack. We started with software-defined networking and network virtualization. Then we moved to software-defined storage and storage virtualization. Then we moved to server virtualization. Combining these three, we end up with a software-defined data center. And then when we sell that online, we have cloud. We have cloud compute, cloud platforms, utility computing. Now we have to move code around across these clouds, and we created application containers. Surprisingly, data remains this final tier of the technology stack that is not completed. It started it. We have data virtualization, but we're missing the containerization. So we haven't finished this transition into a software-controlled world. Each step of the technology stack enabled automation, critically automation. This is what programmable really means. Each of these steps drove exponential cost efficiencies. Each step changed application architectures. They allowed new business models. They fundamentally altered technology roles within technology organizations. The whole structure and operation of technology organizations has changed with every one of these steps. We believe software-defined data, as we're describing it, or programmable data, or data virtualization with this added idea of containerization, or data as code, will be the most disruptive step in the technology stack thus far. We also think it's inevitable that someone's going to do something like this. The key to all of this is, and we'll hear this over and over again, this idea of data containerization, which we think is inevitable. Data, media, and identities containerization is, there's many groups working on all these different parts and ideas. And we'll talk a lot about these going forward. But what we don't have, what's critical here is what we don't have is a standard for data container orchestration. And that's what we're proposing as Accessor. Accessor is a proposed standard for data container orchestration across clouds and across organizational boundaries. So in this column, we're talking about software-defined applications. And in this column, we're talking about software-defined data. We need file standards and orchestration standards. And Docker is a standard file format for application or code containers. And Kubernetes is the orchestration standard for application or code containers. There are many kinds of data containers, and we needed something very reliable and very flexible. We partnered with SQLite to provide the base data container functionality. SQLite is used in commercial aircraft. It's already sort of the standard for edge databases. We partnered with another startup here in Texas, Here, to provide media container functionality. Here's CHIP file is a multimodal media container that adapts to the user's accessibility needs. It's a kind of a programmable media file that holds both images and sound, text, and even video. Working with Here over the last few years, we've constructed a proof of concept with this basic data container orchestration. So one of the key features of these application containers is it enables safe and trustable distributed orchestration. Application containers enable safe and trustable distributed orchestration of application code across clouds. So applications orchestrating code across clouds. What we're proposing is data containers roughly doing the same thing. They're enabled secure and trustable distributed data automation across organizational boundaries and clouds. So here we're orchestrating data containers where Kubernetes is orchestrating code containers. So let's look at this from like another perspective through what happens if we kind of start to look at data virtualization and containerization together. Data virtualization is an existing enterprise technology that helps data management professionals understand and manage data flows within an enterprise. It enables applications to retrieve and manipulate data without requiring the technical details about the data, such as how it's formatted at the source or physically located, and it can provide an extremely valuable master data source for a single customer view. The problem with data virtualization is it doesn't currently extend beyond an organizational boundary. It can only manage data within the organization. It's limited. And as more data is spread everywhere across the world and the internet, this is one of the core limitations of data virtualization. And we're proposing when you put data containerization together with virtualization, it extends that data virtualization all the way up to the network edge and across organizational boundaries, anywhere data moves inside and outside the organization. Another interesting aspect of data containers is similar to networks and servers and applications that have gone through this software control transition. Data can also be more self-aware and responsive. Network servers and applications have become both self-aware and adaptive and responsive to their environment. They operate within predefined administrator policies with instant recovery from every kind of hardware failure. So what would happen if our data were more self-aware and responsive to its environment? Imagine small open source programmable data containers encrypted with keys you control, moving around with smart data contracts that you create that constrain or guardrail the uses of your data. And we're talking personal data and organizational data. So programmable data and this idea of self-awareness is unprecedented in terms of automation. It allows a whole new era of data agility. It enables regulatory and policy automation. It enables distributed and dynamic data architectures. And most importantly, it gives us that transparency and accountability for data usage. It lets us trust our data, secure it. It lets us understand its provenance and its quality. This is a fun little graphic I pulled. This is given, these are posters that go up in schools to tell our children to say no, to protect themselves, and to tell others. The concept here is we should be thinking about our data not too differently than we think about our children. When they're out of our sight, when they're off in the world on their own, they need to be self-aware. They need to be environment responsive. They need to be able to say no, protect themselves, and alert us. So let's look more closely at how we do this. Like how do we in fact control our data when it's out of our hands? And the way to do that is to look at the way we're talking about these smart data contracts. I have had some version of this slide on my wall for about a decade. We repeatedly see centralized control paired with distributed enforcement and policy enforcement across many technology layers. Organizations can set and automatically enforce policy constraints. They can change these constraints across potentially thousands of distributed systems by changing a single policy statement. Smart contracts have evolved into sophisticated distributed policy engines, often associated with blockchains, but they're much older. Smart data contracts build on smart contract technology. They apply the same ideas to automate data agreements. They document data policies, regulations, licenses, and user preferences in language software can execute and automate. So honestly, this has been on I've literally had this slide. It's been in every deck since I started Accessor in 2014. And roll the clock back like 10 years ago, we could do this, we could do temporal. When can I collect and use data about you? We could do duration. How long could I store data about you? We were just beginning to do identity. What persona are you when I interact with you? We had just the tiny beginnings of federated identity back then. We've made major enhancements in this space in the last decade. Location, where can I collect and use data about you? This was rough 10 years ago. It's become much more accurate and more functional. Aggregation, right? How may I aggregate data about you? How can people take our data and combine it with others and move that around? We had no clue how to do this 10 years ago. One of the interesting features of data containers is this idea that we can put them inside other data containers, and then inside other data containers, and then inside other data containers. So we have this concept of nesting, and that allows us to do this aggregation, even all the way out at the edge of the network, where we can have aggregate data nested together with its contracts, cached all the way out at the edge, so that the data is verifiable. The whole data lineage to its source and its contracts is right there functional at the edge. So that we made major improvements over here, but in particular, as it relates to data containers driving that kind of functionality. 10 years ago, we couldn't do any of this stuff over here on the right. The key advancement here is this idea of a zero knowledge proof. If you recall from the other standards we looked at, there was a proof capable reasoner right in the middle of their diagrams, trying to gate the access to the data. This technology has advanced rapidly in the last 10 years, dramatically. So let me explain what a zero knowledge proof is. It allows a party to ask questions about our data without actually really revealing the data itself. So a good simple example would be, say, a loan application, where the bank wants to know that you're of age, you're an adult. They need to know your income clears a certain threshold. They may even need to know sensitive information about you to determine which different kinds of programs you may be qualify for. With zero knowledge proofs, you can be asked those questions to provide answers. You can produce a container with the data in it, gated by the smart contract and zero knowledge proof, that allows the other party to ask these questions, but not see the actual data. So all they would get back are yeses. And that gives us this really powerful functionality over here on the right that we couldn't do a decade ago. Like functional, how can I collect and use data about you? Or third party, with whom can I share data about you? Or third party purpose, under what conditions can I share your data? So we can construct a zero knowledge proof that's a multi-party proof. And that's called secure multi-party computation. And that's what's enabling these third-party use cases. We can now take a collection of different people, organizations. They can share their data in one place. They can decide what questions can be asked of that data, and they can allow people to ask those questions. It's really powerful stuff, and we didn't have these things 10 years ago. There's a whole industry around this. There are multiple companies providing these kinds of services. We're just figuring out now how to plug them into a standard, right? Like the standards we looked at earlier. So taken together, right, this being able to now program these things, many of which we couldn't do a decade ago, a standard for automating regulations like GDPR and CCPA and CPRA and others begins to come into focus, right? We can now kind of imagine automating the right to be forgotten, or the right to data portability, or there's location here, right? Self-awareness, jurisdictional compliance. Imagine automating internal data policies as data flows inside and outside of an organization. And I want to make this really clear down here as well. What I'm trying to communicate is that over time, we've grown in our capacity to automate these things, but we still can't automate everything. Like scoring and tracking. We couldn't back then 10 years ago, and this does not solve for these issues. So while we can't automate all data usage terms that might exist in all data contracts, we now possess the technology to automate most of those terms. And we believe with the proper foundation, future innovators will discover new and novel automation methods. But this is really this is where the rubber hits the road for us. This is exactly what we're trying to program to automate these data contracts. Now I'm going to get into the architecture in a moment, but before, I need to start with sort of a foundation to the architecture. We worked many months on a definition of consent, and we wanted it to be, we understood that the seriousness of this, we understood that if we missed the mark just slightly, that it could have substantial downstream consequences. And so we started, this whole exercise started with a definition of consent. And I can't stress this enough. And we looked at consent as a human experience. in a holistic manner. And we concluded a number of things. We decided the consent had to be defendable. It had to be explicit. It had to be informed, unending, and unlimited, right to control the uses of our accumulated data. Defendable because we have no rights if we can't defend them. That comes from Thomas Paine and Rights of Man. Explicit because we need to be able to tailor uses of our data so that it does what we want and it doesn't do the things we don't want. So it has to be explicit enough for people to individually navigate that divide. It has to be informed. This came from a legal perspective. We invited lawyers into this process, as well as privacy experts and others. And we decided to go all the way up to the top of the legal bar to informed consent, the medical standard of informed consent for any kind of standard. Our thinking is that if the big data platforms, big tech, are able to perform billions of psychological experiments on people, they call these AB experiments, and if they can run experiments that alter our mental state, make us depressed, make us happy, that these are medical, psychological experiments. And so any standard, we decided to go all the way up to the legal highest standard, which is informed consent. Then of course we have the idea of unending and unlimited right to control the uses of our data. We understand organizations may have dates and limits. That's not uncommon for organizational data transactions to have those things. But when it comes to people, we've decided that any standard needs to have an unending and unlimited right to control the uses of our accumulated data for obvious reasons that we got into earlier in the session. So here it is. We hope it's much simpler than the other standards that have been proposed. It's broken into two core parts. We have on the left, we have here this idea of centralized control. We have many master data controllers aggregating our data and controlling its current and future uses from one location. This is a user experience we're describing, sort of managing our data from one location. Architecturally, we're talking about this being fully distributed. And by the way, before I go any further, for those of you that might be data architects, this is a data architecture diagram, but it's as high level as one can possibly be made. And it was done that way for the purposes of intellectual property, so that we could pass these ideas into a nonprofit and it would be secure. Over on the right, we have distributed enforcement. We have this idea of programmable data control and automation with data containers and edge data controllers gating access to the containers, and master data fabrics keeping track of all the containers. So over on the right, what we're doing is we're securing our data with keys and access rules we can control. We can alter all of our data and approved uses as it flows through and is acted upon by external technologies. So let's look at the master data controller in more detail. Oops. So like I said before, we imagine an unlimited number of master data controllers, each focused on the data transactions, the contracts, and the data needs of their respective communities, groups, or to borrow an idea from another one of our partners in our ecosystem, communities of trust, which comes from another Texas startup called Reprivita. These master data controllers are where people, organizations, and groups establish a home for their individual or group data. They also control the uses of that data by others. This is really exciting for us. The solid protocol is out there. It's been in development for a few years. It's an adjustment to the web by its inventor, the great Sir Tim Berners-Lee. The solid protocol proposes, like I just said over here on the left, proposes a decentralized standard for establishing centralized control of data within a distributed architecture. So the exact thing that we were describing over here is that we needed. What we're doing with Accessor is we're adding on to the solid protocol that Tim Berners-Lee is working on in his team, and we're wanting to move data around in containers with contracts. So we're sort of extending another standard that is already in process. There are master data controllers for organizations and for people, and they're going to be very different depending on whether it's an organization or a person. But let's just sort of drill into each one briefly. When we're talking about organizations, we're talking about one location to organize master data. and by extension, all downstream data flows. We're doing this by managing all the organization's data policies or bringing them in from other places, external regulations that apply to internal data, as well as licenses from external data providers. So we're trying to take all the data flowing in and out of an organization and all the contracts that may apply to it and understand that all in one place. I'll get to that in a minute. When we're looking at a master data controller for people, it's the same idea, but now we're looking at people's data. So we're looking at providing one location to control the uses of all of our personal data, and by extension, all downstream data flows. And we do this by managing our application, site, and device personalization settings, trying to put them all in one place. Even things like accessibility preferences, as well as all of our marketing and privacy preferences. And if we do this, then that allows us to exchange containers with organizations to drive personalization. And so looking back at an organizational view of this, it allows an organization to accept user-provided preferences and then use that to drive personalization. The whole hope of this architecture is that if we can create enough transparency and accountability, that people will share exponentially more of their data because they can tailor its use to exactly what they want, and they can dial out the things they don't want. So let's look at the data containers a little more closely. Over here. So we're talking about them being, we're talking about open source, transferable data files. From very beginning, we imagine them being small. The intent of these things is to be small and cacheable. They're really no different than images. They contain a single person's data and media.
You're still on the control data, secure data slide. Not sure.
Yeah, I am.
Okay.
It's one side. I'm bouncing around. Is that okay?
No, I thought you. I guess I assumed you had another slide for.
No. I'm just describing this one slide. Okay, thank you. Okay, so data containers. They're single person's data and media, like images and video, audio. We're imagining, or we actually have functional key pair values, and we're adding the SQL like functionality with the relational data store. To keep things simple and cacheable and fast, we imagine data containers as read-only. We're giving them unique global identifiers. They're all uniquely identified. This allows trustable data transactions and improved data quality, because every data container has that identifier linking it back to a person. Changes to master data sources automatically version and update all cached data containers from here to here. Very similar to how images are cached at the network edge for optimal performance. If anyone's worked with a CDN before and they've had to cache images out at the edge, there's a whole HTTP caching mechanism for that to happen. So we're piggybacking on all that infrastructure that's a good 10, 20 plus years old. Data containers follow a life cycle, just like data. They're created, they're transformed, they're transferred, I mean, they're created, they're transferred, they're versioned, they're deactivated when access is non-compliant, and they're reactivated when they are compliant. And they're eventually ended, revoking all data access, and then finally flagged for deletion. As we've contemplated this idea of data containers in many real-world scenarios, their intrinsic privacy became their most interesting property. We quickly realized data owners, they could and they would, and after a bit of thinking, we decided they should encrypt their data with keys they control before placing their data inside containers for distribution. We now consider this behavior of using one's encryption completely unavoidable. It's very difficult to stop. It's potentially impossible to stop, in fact. And it's an unavoidable privacy-preserving property of our standard. So let's draw a parallel here. Imagine sending an encrypted message to a friend, right? Via regular mail, the old-fashioned way, paper, envelope, and stamp. Now imagine the delivery person knocking on your door. They've opened your envelope, they've pulled out your message, and they're telling you they can't deliver it because it's encrypted. That's not good. It became very obvious to us trying to build these systems that any trusted intermediary who attempted to limit the use of bring your own encryption would quickly destroy their credibility and trust. This is something we want people to really think about because it's really interesting. It's an intrinsic and unavoidable privacy-preserving property. That's a lot of words for data containers, and it continues to fascinate me and the team. Edge data controller. Okay, so the edge data controller, imagine this as code that is actually in the browser, like in JavaScript, or it's code libraries that would go into a desktop app or into a server app or into a mobile app, an Internet of Things device or sensors. That this edge controller is an executable and it goes inside the applications that are running on these devices. It gates and controls all access to the data containers while enforcing smart data contract terms. The edge data controller is like a database executable interacting with a data container that's like a database file. They're like little data bodyguards or intelligent agents. We imagine them becoming more and more intelligent over time and being able to scan and assess their environment. Data containers are inaccessible without the cooperation of an edge data controller providing secure key distribution and gating all data interactions per the terms of the attached smart contract, which defines the terms of the zero knowledge proofs and the questions that could be asked of our data. And of course, the edge data container in coordination with the master data controller APIs enable this data container lifecycle. And then here on the upper right, connecting to our master data sources, we have multiple master data facts. Just like we have multiple master data controllers, and many edge data controllers and data containers, we imagine there being multiple master data fabrics as well, perhaps one for every community of trust. And they track the whole container lifecycle, logging and auditing all replicas of data containers, all aggregates, transactions, the physical and digital locations of these data containers, as well as tracking the global data lineage, as well as the global contract lineage. And I need to make a quick announcement because it was too late to alter any of our materials, but we're in the process of setting up the Data Freedom Foundation, and I'll be stepping over and running that. We've decided to create a nonprofit open source standards group for data and digital civil rights. We're exploring working with the Linux and Apache Foundation, and the 2 patents that we're describing in this architecture I'm giving to the nonprofit. I've decided to give this IP to everyone. I've decided it's what's right. I've decided it's what's needed to be successful. And I've decided it's what's needed to create a universal standard for contractual control of data or digital rule of law. As the Archbishop declared in our keynote address, data must be made transparent and accountable. An Accessor, or the Data Freedom Foundation, I should say, is proposing an open source nonprofit standard to accomplish these goals. If y'all would like to open it up to questions, I think we have 15 minutes. Not bad.
Yeah, very good. Very interesting, very provocative. I think you explained this on one of your architecture slide, but this seems like a huge endeavor to get this environment up and running. And who actually runs it?
Right. That's why we're pairing the nonprofit with the IP with Accessor. So let me go back to the architecture slide. We're going to have to sort of bootstrap this up. We're taking a consultative approach to this. In our first phase, we're building out the ecosystem. We're asking people to join the standard and to help us create the technology. We have a proof of concept already with the data container lifecycle and with this preference center across many organizations. We're in the process of combining these 2 proof of concepts and adding the smart data contracts. As far as adoption goes, yeah, just like we've gone through an adoption curve for programmable networking, and then programmable storage, and programmable compute, and then cloud, and every one of these has gone through an adoption curve. And so we expect something similar with traditional data. This will have to start slow, and we'll have to build an ecosystem, and people will have to want to join it. They'll have to want to build applications that are compatible with this sort of standard. And I envision an alternate data ecosystem, if you will, a set of companies and services that are functioning and treating data completely differently than others. You have to kind of adopt the standard or not. It's kind of Boolean. You can't kind of halfway adopt it. So yeah, we're looking for our early innovators and early adopters. So
what are the implications for the individual? Because this comes down to personal data of an individual or an organization, right? But let's just take the individual first. what do they have to do, and how much time and mental energy do they need to spend to participate and configure their data container and get it up? And I'm thinking of, Facebook's many attempts to improve the privacy configurations it offers to the users. And my sense is that, they've made it much more configurable. Now, this is obviously, it's just one small arena. And I don't know if there is any parallels to that, but it seems to me most users ignore that.
Yeah. There's in the product management world, we have this concept, this kind of competing concept, right? This duality of what we call configuration versus convention. And we can think of Mac products as being a convention, in that there's often only one way to do things. People often consider them simpler and easier to use. And then we have, on the other hand, kind of Windows products that they definitely lean more towards configuration. And the people that use those products, they use it because of the power and complexity and the configuration that comes with them, but they're also considered more complicated to use. So we're imagining not one user experience for consumers. The simplest version, we're picturing something really as simple as rights, the right to data portability, the right to jurisdictional restriction, whatever the rights menu is, they just simply check the boxes and those rights apply to their data. On the more powerful side, we can imagine people scripting their data across multiple platforms, actually orchestrating those platforms to do things in concert with one another, events that are occurring that kick off data flows between organizations. So we imagine there being more power users that are able to go into something that might look like a low code or no code environment where they can actually script events and data across multiple services. Now, regarding adoption, we can take all of these use cases we're considering, and we think of this user adoption as a big hump, kind of like a mountain to get over. And we can take all the use cases that we're considering and that we're talking to people about, and we can classify them into one of two categories. They're either post the mountain climb, right? They involve users adopting the technology en masse, right? And then there are many other use cases that don't require that. We call that kind of pre-paradigm shift. And so we're going to be focusing in a consultative way on what we call pre-paradigm shift opportunities. Think, for instance, like edge computing. There's no standard there to manage data out at the edge. The standards in edge computing only go out to the code container, not the data container. That's a pre-paradigm shift use case. It's a huge use case. So we have plenty of opportunities to work with standards groups to take this single architecture and use it in multiple places. And to initially target those use cases that are what I call pre-paradigm shift, that don't require user awareness or adoption. It's just in the application, and it provides all these extraordinary benefits to the developers and to the organizations that use it.
Interesting question here. How can you prevent those who read the data from copying and redistributing it? I can always point a camera at my computer screen.
True. Yeah, this is a good one. We have things in our house, and then even things in our house, we put them in safes, and then we have things that we keep outside of our house in, say, like a safety deposit box or in a bank. And then there are things that we keep in our car, and there are things we don't keep in our car, right? Things we bring and we make sure we don't leave in our car. But this idea of locks and containers, there's no lock and container for everything. When we talk to people about the use cases, no system is perfectly secure. And so one has to look at the value of the data that we're putting in the containers, right? And then evaluate the difficulty of getting into one. If our data was sitting over at enterprises in millions of containers, individually encrypted with keys we controlled, we would have a very different security landscape.
So that's suggesting that, for instance, I was thinking of myself here, what would I put in my digital safe box, right? My digital container.
Well, it would be all your data would be the idea. So let me give you a really concrete example. So you think your medical.
But wait, but you're
Okay.
saying that maybe you were suggesting that maybe we put only some things in there, the most valuable things, like your social security.
Oh, well, no, what I was saying is that we need to be careful what we put in it. We need to assess the risk, right? So this paradigm is encryption agnostic. We're not describing any particular paradigm for encryption. We've already uncovered several different ways of doing the encryption. And we anticipate there'll be more encryption paradigms. And we even imagine there being different kinds of data containers that for different payloads. So it's when we're looking at this as an architecture and as a data protection mechanism, we have to do that same assessment that we think about the value of an item and is it appropriate for that box and for that lock.
Right. Another question on any input from the United Nations or other groups like that.
Yeah, we've had some contact with EU regulators that worked on GDPR, and we received enough of an encouraging response from them that we've made the flip to move all the IP into the nonprofit. We would like more contact though. Please, if you think that this is relevant to other standards bodies or to other standards groups, definitely reach out and or share the information with them. That's the point of being here and talking about it.
Another question, who will be owning or responsible to make this happen in an organization?
That's interesting. So, you know, it affects so many people in the organization. I think it would be, our early adopters are going to be developers. They want to prototype and innovate and test the technology and see what it can and can't build. I think, I'm sort of guessing here, but this is why we're here at MIT speaking to this group, is I think chief data officers are going to be the ones that can champion this sort of technology when it starts to proliferate, when we can grow the ecosystem large enough that it becomes a real option for businesses to use pervasively. What's interesting is that it affects privacy experts, it affects marketing, product, many other parts of accessibility, many other parts of an organization. So it's a chance for a data professional to now work with many different peers on a common architecture and standard that advances many people's agendas.
Okay. So this is my question here. I'm just trying to think how this might apply to me as an individual, and I also run a small company, right? So
Yeah.
what is this going to require me to do, both as an individual who has personal data and as an organization that has very, doesn't have a huge amount of resources or time, mostly time, to spend on a lot of stuff. But I can see, what is the threat that would make me want to spend time, which is, someone gets my social security number. I see that as a threat, and, identity theft, that's a threat, rather than spending money on some service that I don't know who they are, right? And same thing for the company, I suppose, right? Someone gets a hold of my bank account and routing number, that to me is a threat and would motivate me to spend some time to implement something like this. But I don't know what the owner, what the requirements would be for doing it.
I would say smaller businesses would be later in the adoption life cycle when this kind of technology has been adopted more pervasively throughout the data ecosystem. What you would be describing would be later in the adoption cycle where it's already embedded in everything and all the products that are moving data around. When you go to a registration screen, you would just click a button and say register. You could control what data that entity had, as well as the questions they could ask of it, even after it was shared. You buy a medical network that you're a part of with your health insurance, made up of many companies. That's what we call a community of trust. You could go to one place in that community of trust, and you could see, say, all of your medical data across all the different parties. But you'd be able to move that data around, and the rules that you would use to control that data would apply everywhere you move that data. So if you needed to move it out of network to other specialists, they'd all be using the same standard for how the contracts work and for controlling how the data can be used or not be used.
So if I change health plans, then I would have to give permission to move the data from one health provider.
Yes, you would. Yeah, but it would be portable. You'd be able to move it around with a click of a button, would be the idea. And if they needed to ask different questions of your data, you would have a chance to see that and understand it and either accept it or not.
You know, we've done research, my company, on data exchange platforms, and that's the same kind of thing is evolving there, where if you're have data that you want to share or sell, these platforms are making it so that you can configure who can access, well, who can see it, what's available, what they can access, for how long they can access, or what they can even do with it. Maybe they can't even see it, but they can manipulate it, run an algorithm against it or a query against it and get a result set only. So I guess this in some ways is a little bit analogous to what you're.
It would be. Imagine what they do, but then imagine it being based on an interoperable standard.
Yeah.
So that even data between those kinds of companies could be moved around and exchanged and shared. What this enables, what we're beginning to kind of scratch the surface of, is this idea of an information economy. It goes back to you know, sort of what does rule of law do? If we can move around data and do this sticky tagging, this tagging of our policies or of our contracts about how it can be used. If we can build this, it should smooth out a lot of the problems we're seeing in our digital landscape.
Well, I was about to ask, we have 3 minutes left, but what are the biggest threats that this solves? I mean, you started out saying that, you know, people are manipulating us with data. I mean, people have been manipulating us for eons, right? Through advertising, things like that. And personalization has a good side.
Right, it does.
You know, all this personal data, you know, if it's being used to make your life more convenient as a consumer, that's goodness. Of course, in the hands of a malevolent actor, whether it's a commercial or government, is a huge problem, obviously. But I'm wondering if you see other major threats.
I would say those the threat is that data is not its nature right now is that it's not transparent and accountable. That we're limited with how we can share it because we have no control over how it's used after it's shared. And so what we're solving for here is the ability to share exponentially more of our data and to more tailor its uses so it does exactly what we want it to do and it doesn't do anything else. And if we can do this, then it really is a foundation for a digital economy, for the creation and preservation of digital wealth.
So it's not just, you know, locking the door and closing the gates. It's really, it's going to, and this is what we say in the data exchange world, this will increase the shareability of data. If we have more controls around it, more companies would be willing to put their data up there if they can control who can see it, access
and the questions
it.
What we're doing with the zero knowledge proofs is we're controlling the questions that are asked of it.
Yeah.
And these are the functions these are the levers that we have that we can play with. And these are, and it's a growing list is the story that I'm trying to tell, is that as I've had this on my wall for a decade, I've been checking these things off, right? Trying to figure out, how do we do this? How do we do this? How do we do this? How do we do? And I think over time we'll find this array of levers that we have, it will expand. I've already witnessed it expanding. It's doubled in its footprint in the last 10 years.
What we're seeing with the data exchange market is that there's a lot of service providers who are building on top of these exchange platforms, services, you know, value-added services like, you know, lineage, data quality, reconciliation, deduplication, you know, customer matching, things like that, that, you know, the provider itself isn't delivering, but customers may want, and then they can just select those capabilities as services, that add-on services.
It should facilitate the ecosystem. It should make it more interoperable. It should make it, again, more transparent and accountable, which is our ultimate goal.
Yeah. Well, excellent. Very fascinating. A huge, huge endeavor. Thank you for your energy and your persistence here. I think love to see this come to pass. And we should keep talking about this at every MIT event. So with that, I'd like to thank you and our audience for all their great questions.
Thank you, everyone.